We have another question on simultaneous equations problem. We were discussing problems on simultaneous equations. Now it says if the numerator of a fraction is increased by 2 and the denominator is decreased by 1, it becomes 2 upon 3. If the numerator is increased by 1 and denominator is increased by 2, it becomes 1 upon 3. Fraction becomes 1 upon 3. Find the fraction. In all these questions where we have to calculate either a number or a fraction or age or whatever, we assume let the fraction be x upon y. Fraction will be always in the form of this numerator divided by denominator. Numerator divided by denominator. Now it says if the numerator of a fraction is increased by 2. So increased by 2 means plus 2. And denominator is decreased by 1. Decreased means minus 1. It is going to become 2 by 3. It is going to be equal to 2 by 3. From the first condition, if the numerator is increased by 2 and the denominator is decreased by 1, the fraction becomes equal to 2 by 3. So from the first condition, I get this kind of an equation which I am going to cross multiply and simplify. Like this will become 3x plus 6, 2y minus 2. 3 will multiply this side numerator. Y minus 1 will multiply this size numerator. Bring x and y terms to the same side. 3x minus 2y is equal to minus 8. Let's name it equation 1. We brought x and y terms on one side. Constant terms were shifted to right hand side. Now the another thing is, if the numerator is increased by 1, in the second condition, if the numerator is increased by 1, numerator is x, it is increased by 1 and denominator is increased by 2 and denominator is increased by 2, so y plus 2. The fraction becomes equal to 1 upon 3. The fraction becomes equal to 1 upon 3. So from the second condition we got the equation x plus 1 upon y plus 2 is equal to 1 upon 3. Numerator was x, it is increased by 1. Denominator was y, it is increased by 2, and the fraction becomes equal to 1 upon 3. Let us cross multiply. 3x plus 3 will be equal to y plus 2, or write it in the standard form. Bring x and y term on one side, constant term on another side. 3x minus y is equal to 3 will go to that side, minus 3 plus 1, that is minus 1. Equation 2. Now we are going to solve equation 1 and 2. It is very simple because already x coefficient in both the equation 1 as well as 2 are equal. The coefficient of x is here 3x, coefficient of x is 3x here. So what I can do is I simply will subtract equation 2 from equation 1 because I am using the method of elimination. For elimination you have to make x coefficient or y coefficient equal. Here I have already the x coefficient equal. When I say x term equal, that means coefficient of x in the first equation should be equal to coefficient of y in the x in the second equation, and also here signs are same, plus 3x plus 3x. So if the signs are same, what we do is we simply subtract. Let us subtract. Minus, plus, plus. We change all the signs. 3x minus 3x will cancel. Minus 2y plus y will become what? Minus 2y plus y will become minus y. Minus 2y plus y will become minus y. Minus 8 plus 1 will become minus 7. So y is 7. We got the value of y as 7. Your denominator is 7 because y was denominator. Now let me get the value of numerator by putting the value of y in either in equation 1 or in equation 2. Because if I substitute the value of y as 7 in, suppose in equation 1, substitute y is equal to 7 in equation 1. Suppose I put it in equation 1. If I put this value in equation 1, what will happen? 3x minus 2y, that means 2 into 7 will be equal to minus 8. Or 3x will be equal to minus 8 plus 14. Because 2 sevens are 14. This is minus here. If I shift to that side, it will become plus 14. 14 minus 8 will be 6, or x will come out to be 2. So x is 2 and y is 7. So the fraction will be, the required fraction would be 2 upon 7. This is your answer. X upon y will be 2 upon 7. We had assumed the fraction to be x upon y. X upon y comes out to be 2 upon 7. Let us check it now whether your answer is correct or not. I'll tell you once or twice, then I'm going to avoid it. You will do it yourself. If 2 is added to 2 upon 7 is the fraction. If 2 is added and 1 is subtracted, it will become 4 upon 6. 4 upon 6 means 2 upon 3, which is the first one, condition. If 1 is added, 2 upon 7. If 1 is added and 2 is added, it will become 3 upon 9, that is 1 upon 3, which is the second condition. So in both the ways I saw this fraction is satisfying the condition given in the question, hence your answer is absolutely right. Next question is based on 2 digits number. Now you know that if I take a 2-digit number, for example, let me take as 35. For example, just to explain it to you, if a 2-digit number is 35, 5 is the unit digit, 3 is the tens digit. In the expanded form, how do we write it? We write it 10 into 3 plus 5. In the expanded form, we write it as 10 into 3 plus 5. This is tens digit and this is unit digit. Now he said the sum of the digits of a 2-digit number is 5. If the digits are reversed, the number is reduced by 2. So we assume always in 2-digit number, we assume 2-digit number as 10x plus y. Actually we write in the expanded form. The number is xy, the number is xy, like 35. 35 is written as 10 into 3 plus 5. So xy, a 2-digit number xy, is written as 10x plus y. Digits are x and y, but 10 shows the place of x. X is in the tens place. So we assume 2-digit number, we assume a 2-digit number 10x plus y. He says the sum of the digits of a 2-digit number is 5. So, digits are x and y only, not 10x and y. Digits are 3 and 5, not 30 and 5. So the sum of the digits x plus y is equal to 5. The first condition given is that the sum of the digits of the 2-digit number is 5. The sum of the digits of a 2-digit number is 5. If the digits are reversed, the number is reduced by 2. What does it mean? This is the number 10x plus 5. If I take the example of 35 only, 35 is a number. If I reverse it, what will it become? 53. It will become 53. 35 becomes 53 on reversing the digit. The 53 is larger than 35. But if I had assumed the number to be 53 and I reverse the digit, number will become 35. So the number becomes less than the original number. Here the condition is something like that. Number was 53. For assumption, if number was 53, on reversing the digit it becomes less, because it says if the digits are reversed, the number is reduced by 2. The number is reduced by 2. What does it mean? What does it mean? If the digits are reversed, the number is reduced by 2. What does it mean? That 10x plus y, if the number was 10x plus y and it became 10y plus x, it became, the number is reduced by, not 2, 27, sorry. Number is reduced by 27. Number is reduced, if the digits are reversed, the number is reduced by 27. That means the original number minus the reverse number is going to be 27. What is the original number? Original number (10x plus y). Reversed number what is the reverse number? 10y plus x is reduced by 27 is reduced by 27. So if I reverse the number, so 10x plus y is the original number. If I reverse the digit, suppose 10y plus x, the difference of two numbers is 27. It is reduced by 27. It is reduced by 27. So let us see. Original number minus the reverse number is 27. We saying when number digits are reversed, the number is reduced by 27. The number is, that means new number which we have obtained is reduced by 27. That means the difference between the original number and the new number is 27. Let us solve this. 10x plus y minus 10y minus x is equal to 27. 10x minus x is 9x minus 9y will be 27. It will be divisible by 9. X minus y is equal to 3. Equation 2. Now you have two equations, equation 1 and 2. Solve equation 1 and 2, get the values of x and y, and if you get the value of x and y, then I can get the required number. The first equation was x plus y is equal to 5, equation 1. So what I'll do is, I'll add, because y as well as x coefficient are equal, but if I add, then y terms will eliminate. So 2x is equal to 8 or x is equal to 4. The value of x comes out to be 4. Substitute x is equal to 4. Substitute x is equal to 4 in equation 1 or in equation 2. Let us write it here. Substitute x is equal to 4 in equation 1. In equation 1. What is the equation 1? Equation 1 was x plus y is equal to 5. So x is 4 plus y is equal to 5. So y will be 5 minus 4, that is 1. So x is 4 and y is 1. I have got the value of x as 4 and y is equal to 1. So required number was, we had assumed number to be 10x plus y. 10x plus y. What is the value of x? 4. So it will become 10 into 4 plus y is 1. So 41. The required number is 41. Required number is 41. Now you can see the sum of the digits of the two-digit number is 45. 4 plus, he said the sum of the digits of a two-digit number is 5. So 4 plus 1 is 5. The sum of the digits are 4 and 1 only. So 4 plus 1 is 5. The another thing which it says, if the digits are reversed, suppose we reverse the digit, so 41 will become 14. 41 will become 14. The difference between 1 and 14 will be 27. He says, if the digits are reversed, the number is reduced by 27. The number is reduced by 27. The original number becomes 27 less. So, this is the original number 10x plus y. We reversed the digit, it became 10y plus x is equal to 27. From that we got the second equation. We solved the equation 1 and 2. We got the value of x and y. We substituted the value of x and y in the number 10x plus y. X was 4, y was 1. So 10 into 4 plus 1, 41. And now let us check, as I checked already, 41, the sum of the digits is 4 plus 1, 5. And if I reverse the digit, 41 becomes 14, and the difference of 41 and 14 is 27, which was the second condition, reduced by 27. The next number in the series of questions which we are doing based on a 2-digit number is, the tens digit of a 2-digit number is 3 times the unit digit. The sum of the number and the unit digit is 32. Find the number. Whenever a 2-digit question is given, first of all assume the number to be number to be 10x plus y. This is number xy written in the expanded form, 10x plus y, where y is the unit digit and x is the tens digit. Now he says the tens digit of a 2-digit number. The tens digit of a 2-digit number, tens digit here is x, is 3 times the unit digit. Unit digit is y. So he says number 1, x is equal to 3y. The tens digit of a number is 3 times the unit digit. So x is equal to 3y, or I can write it x minus 3y equal to 0. This is first equation I have obtained. There will be 2 conditions given. From both the conditions we have to write the equations to obtain equation. We will get we'll get a system of simultaneous equations which we will have to solve finally. Now let us see the second condition. The sum of the number. What is the number? 10x plus y, not xy. We assume the number to be always in the expanded form. The sum of the number 10x plus y plus and the unit digit. What is the unit digit? Unit digit is y, is 32. He said the sum of the number, the sum of the original number, this is 10x plus y is the number, 2-digit number, plus its unit digit is equal to 32. What does it mean if I solve it? It means 10x plus 2y is equal to 32. Or I can even divide, doesn't make any difference. Let's take equation 2. Now solve equation 1 and 2. What I'll do is, I can multiply this equation by 10. Let me multiply equation 1 by 10. Multiply equation 1 by 10. Why by 10? Because here 10x is there, I'll convert this into 10x. So 10x minus 30y is equal to 0. 10 into x is 10x, 10 into 3 is 30 is equal to 0. Second equation is 10x plus 2y is equal to 32. What we will do is, let us subtract here, here, here. Now this 10x minus 10x will cancel. It will be minus 32y is equal to minus 32, or y will be equal to 1. The value of y comes out to be 1. So we have been able to obtain the unit digit of the number, which is y. Now let us substitute y is equal to 1 in equation 1. Substitute y is equal to 1 in equation 1. If I put in equation 1, I could put it in equation 2 also, but equation 1 seems to be simpler. So you substitute the value where you have to do less calculation. That is the common sense. X minus 3y, 3 into 1 is equal to 0, or x is equal to 3. So the value of x is 3, the value of y is 1. So the required number will be 31, because it was 10x plus y is 10x plus y, and x is 3, so 31. It comes out to be 31. So the required number is 31. Now you can check your number whether it is right or not, in the sense that it says the tens digit is 3 times the unit digit. Tens digit is the 10 digit of the number is 3 times the unit digit. In 31, the 10 digit is 3, which is 3 times 1, which is 3 times 1. The first condition is satisfied. In the second condition, he says if you add unit digit to it, then it will become 32. Number was 31. If I added the unit digit to it, it became 32. So this number satisfies both the condition. There will be no other number which can satisfy. If your number was by chance you calculated wrong, that number will not satisfy both the condition. There is only one number which will satisfy this condition, both the conditions together. That is that the tens digit is 3 times the unit digit, and if unit digit is added to the number, it becomes 32. This will be satisfied only by 31. No other number will be there. If you by chance you calculate it to be 27, then it will be wrong, or 32 it will be wrong, or 42 it is wrong. So to check back, it is the best way is to put the values in equation 1 and equation 2 and see whether it is satisfied or not. A 2-digit number is such that the tens digit exceeds twice the unit digit by 2, and the number obtained by interchanging the digit is 5 more than 3 times the sum of digits. Find the number. Again, it's a 2-digit number problem. Let us assume the 2-digit number. Let the number be 10x plus y. It's a 2-digit number. We assume the number to be 10x plus y. A 2-digit number is such that the tens digit, what is the tens digit? X, exceeds twice the unit digit. X is the tens digit, exceeds twice the unit digit by 2. It says the tens digit exceeds twice the unit digit by 2. That means the tens digit is the difference between the 10 digit and double the unit digit is 2. That is equation 1. That is equation 1. X minus 2y is equal to 2. Now he says if the number obtained by interchanging the digit. Now let us interchange the digits. Interchange the digit means reverse the digits. So 10y plus x. Original number was what? 10x plus y. Now we interchange the digits. In place of x I put y. In place of y I put x. The number obtained by interchanging the digit is 5 more, is equal to 5 more than what? Then 3 times the sum of digits. 3 times the sum of digits will be 3 into x plus y and plus 5. It says if we obtain a number by interchanging the digits, the original number was 10x plus y. When we interchange the digits, the number became 10y plus x. Will be equal to 3 times the sum of digits plus 5. Now let us solve this equation. 10y plus x minus 3x minus 3y, I shifted this to this side, became minus, is equal to 5. Or x minus 3x is minus 2x plus 7y is equal to 5. This is equation 2. Solve equation 1 and 2. For solving equation 1 and 2, I'll make the x term equal by multiplying equation 1 by 2. Let me multiply equation 2 by 1. 1 by 2, it will become 2x minus 4y is equal to 4. Now what has happened? I have multiplied this equation with 2, so x coefficient becomes same, and 1 is negative, 1 is plus, so we will add them. Eliminate it. 7y minus 4y is 3y is equal to 9, or y is equal to 3. This is the unit digit. We have got the unit digit as y. Now put y is equal to 3 in equation 1. Put y is equal to 3 in equation 1. Equation 1. In equation 1. Equation 1 is x minus 2y is equal to 2. So x will be 2 plus 6. That is 8. X has come out to be 8. I have got x as 8. I have got y as 3. So required number will be 10x plus y. X is 8, so it will be 83. Required number will be 83. Now let us check whether this number is correct or not correct by seeing the condition. X is the tens digit, so 8 minus double the unit digit. 2 into 3 is 6. 8 minus 6 is 2. So first condition is satisfied. 8 minus 6 is 2. Now if we reverse the digit, it becomes 38. 83 will become 38. 3 times the sum of digits. 3 times the sum of the digit. Digits were 8 and 3 only, and plus 5. So 8 and 3 is 11, 33 plus 5, 38. So 38 is equal to 38. So this condition is also satisfied. The number 83 satisfies both the condition given by the question. Hence, your answer is correct. This is the last problem I am doing on 2-digit number for you. After that, I'll do the age questions, age-related questions. A 2-digit number is obtained by multiplying the sum of the digits by 8. Again, 2-digit number, let the 2-digit number be 10x plus y. It's a 2-digit number in which unit digit is y and tens digit is x. Now, if a 2-digit number is obtained by multiplying the sum of digits by 8. So, a 2-digit number is obtained by multiplying the sum of the digits by 8. X plus y. X and y are the digits. So, we added the digits x and y and multiplied that by 8. We will be able to get the 2-digit number. That is what it's saying. Let us see what do we get from this equation. 10x plus y minus 8x minus 8y is equal to 0. Or we get 10x minus 8x is 2x and minus 7y is equal to 0. This is equation 1 we have obtained from condition 1. He said the 2-digit number is obtained by multiplying the sum of digits by 8. So 2-digit number is 10x plus y. The sum of digits is x plus y. If it is multiplied by 8, you get the 2-digit number. I solved this equation 10x plus y. I brought this to this side. minus 8x minus 8y is equal to 0, 10x minus 8x is 2x, y minus 8y is minus 7y is equal to 0. Now let us see what is the second condition. Also it is obtained by multiplying the difference of digits by 14 and adding 2. Also it is obtained. So the same number is also obtained by another method. What is that? Multiply the difference by 14. The difference of the digits multiplied by 14 and by adding 2. By adding 2. The 2-digit number is also obtained by multiplying the difference of the digits by 14 and adding 2. So he will give you two conditions. He will give you two different conditions, and you will be by the application of that, you will be able to get two equations. And once we get two equations, we'll solve them for x and y. Now, like for example, how will I get this? 10x plus y minus 14x minus plus 14y is equal to 2. I shifted this to the side, became minus 14x plus 14y is equal to 2. 10x minus 14x is minus 4x, and y plus 14y is 15y is equal to 2. Equation 2. Equation 1 is 2x minus 7y is equal to 0, and equation 2 is minus 4x plus 15y, y plus 14y, 15y, and is equal to 2. So what I'll do is I'll multiply this equation by 2 to make x terms equal. X term means x coefficient equal. 2 2s are 4x, I'll get 2 7s are 14y is equal to 0. And the second equation is minus 4x plus 15y is equal to 2. So when I add these two equations, because it is plus 4x, it is minus 4x, when I'll add, they will be eliminated. You will get 15y minus 14y is y is equal to 2. So you got the unit digit as 2. You got the unit digit of the number as 2. And let us put now the value of y in equation 1. Substitute or put y is equal to 2 in which equation? In equation 1. I told you always pick up the simpler equation with common sense to do less work. 2x minus 7y, 7 into 2 is equal to 0, or 2x is equal to 14, x is equal to 7. So x is 7 and y is 2. So what will be your required number? Required number will be (10x plus y). That is 10 into 7 plus 2. That is 72. 10 7s are 70, 72. So this is your required number. Does it satisfy the conditions what were given? The 2-digit number is obtained by what? He says add up the 2 digits. 7 plus 2 is 9 and multiply by 8. So 7 plus 2 is 9. 9 into 8 is 72. So first condition is satisfied. Second condition is it is also obtained by multiplying the difference of the digit by 14. The difference of the digit 7 minus 2 is 5. If I multiply it by 14, 14 5s are 70. 70 plus 2 is 72. So both equations are satisfied. There will be only one possible number which will satisfy these both conditions. And if even one of the conditions is not satisfied, that means there is something wrong with your calculation somewhere. So always at the end of the question, just when you are revising your question, just check whether the number obtained satisfies the condition which you given in the beginning of the question, to see whether your answer is correct or not. This should be followed during examination or your test, that you should be able to you should be able to see that your answers are correct or not.